Hello everybody and welcome to my DebConf 20 talk, Building Enterprise-Grade Postgres Services via Debian Packages and Systemd Integration. My name is Michael Banck. I'm a long-time Debian developer and a member of the Postgres packaging team. I work at Creative and our tagline is open source for business. So we've been doing most of the PostgreSQL packaging over the last couple of years. This is the uploaded statistics of the package PostgreSQL team. And as you can see, the red bar and the orange bar and the green bar, that's Creative employees. That's Christoph Berg mostly, but also me and my colleague Adrian. So we've been doing most of the packaging of the extensions and the Postgres server over the last couple of years. So I want to start with just a few words about Postgres itself. Maybe you haven't heard so much about it. So Postgres claims or prides itself to be the world's most advanced open source relational database. Now, what I find very important is that Postgres is vendor neutral. So there's other open source relational databases like MySQL and MariaDB, but those are controlled by one vendor. And Postgres is not controlled by one vendor, and there's commercial supports available from multiple companies, and also the developers are working at multiple companies. Postgres has a BSD MIT style license, so there's no copyright assignments, there's no open core, and there's no dual licensing. It's very free in that regard. Now, historically, Postgres has had a focus on data integrity, safety first, and a good track record for being rock solid and not eating your data. It also has a good and consistent coverage of the SQL standard, but it also has useful modern extensions. So you got JSON there, you got all kind of other things that you might want to have in a modern SQL developer experience. It also provides most common enterprise features like replication, encryption, auditing, logging, all that kinds of stuff. So it's really possible to use it as a mission critical database in your company. And it has a large number of extensions and associated projects. That's because it's been developed as an extensible relational database system. And most of these extensions are packaged in Debian along with Postgres server. So I first want to just spend a few minutes talking about how Postgres is packaged in Debian and Ubuntu, because Ubuntu just takes the Debian source packages and uses them verbatim, basically. So this is just a word cloud of all or most of the Postgres extensions in Debian. Some of those are actually in core, so they're shipped by the Postgres server or the Postgres contract package, but most of them are actually packages you can install in Debian. So there's quite a lot of them. There's data types, there's foreign data wrappers to federate with other databases like Oracle or MySQL. There's admin stuff, there's replication stuff like pglogical, and monitoring stuff like pgstat statements, or auditing like pgaudit. So there's lots of extensions there, and they're all available in Debian as an apt install. Now, for Postgres itself, there's the problem that Debian packages only one Postgres release per version. So you have, of course, several Debian versions, but you also have several Postgres versions. Every Postgres version, so Postgres releases once a year, basically, and every release is supported by the community for 5 years, which is pretty good for an open source project. So that means that you always have lots of Debian and Postgres versions supported in parallel. And of course, the solution is to make the packages for all the Postgres versions co-installable. But still, Debian would like and does only ship one major version. So Bullseye will probably have 13, Buster has 11, Stretch had 9.6, Jesse had 9.4. So basically every 2 years you get the next second Postgres version, because the Postgres release process, it releases in Q3, and then Debian usually releases in Q2 of the next year, and that pretty much aligns very well together. So Postgres just makes the freeze, and then Debian releases a couple of months later with the then current Postgres version. Now, users might want to try new Postgres versions. They want to try to develop on new Postgres versions, but they don't want to, like, how they're going to do this. I mean, if you're on Buster right now, you cannot get 12 or 13 in Debian. Users might also want to run Ubuntu and not Debian. Well, okay, Ubuntu also has one version. But also users want to upgrade Debian maybe without upgrading Postgres. So it could be that you are running 10 and you're pretty sure that 10 runs really rock solid and you don't want to touch that, but you want to upgrade Debian from Stretch to Buster, for example. Now, the solution to that is app.postgresql.org. So that's a collaboration between the Debian Postgres team and the Postgres Global Development Group, or Postgres developers. So that means that it has a proper postgresql.org domain name, but it's actually developed and run by the Debian Postgres developers, which means mostly my colleague Christoph Berg. Now, this is an app repository and it hosts packages for all supported Postgres versions built for all Debian and Ubuntu releases. So basically, it's kind of like a super backports. You have 6 Postgres releases, 9.5 to 13, and you have 7 Debian and Ubuntu releases. You have Stretch, Buster, Bullseye, and Unstable, and you have the LTS releases. And then you have 4 architectures. So recently we added ARM64, but you also have AMD 64, and you have i386 and PowerPC. 64 little endian. So that means it's 168 targets. So if there's a Postgres extension that needs to be built on 4 architectures for 7 Debian and Ubuntu releases, and as most extensions are Postgres are version sensitive, for 6 Postgres releases. So that's a lot of packages to build. You cannot do that by hand. So what we do, or what we have, is we have a Jenkins instance and we use Jenkins Debian Glue to generate jobs. And this is hosted at PGDG build. PGDG again stands for Postgres Global Development Group. And back then, I mean, we've been doing this for 7-8 years, and we started running auto package tests pretty early on. Nowadays, of course, CI Debian.net and Salsa CI do that, but we've been doing that for a while, and this was also a very good quality assurance thing. So some statistics for this, the orange line is the number of source packages. So that's basically how many packages or projects we've packaged. And this went up from maybe 30 in 2013 to about 250, 300 nowadays. And then the black line, that's all the files, all the binary packages. And you can see that it's going up if an architecture or a new suite is added, and then it's also getting down when, for example, some suite is retired or some cleanup is being done. Right, so what you can see is that it's basically going up linearly. Now we have 30,000, almost 30,000 Debian packages on app.postgresql.org. So basically you have all what you need in Postgres at your fingertip by using the app.postgresql.org repository. Okay, so now maybe just a few words about how actually Postgres is packaged in Debian, how this works, how this co-installability works. And it does work via the postgresql-common framework. So this allows multiple major versions to be co-installed. So you have user, lib, postgresql, 10, bin, something or so. And then you have instances or clusters. Those two are interchangeable. You have them identified by version or by cluster name. For example, 12-main or 12/main. So 12 is the version, main is the cluster name. And then the whole cluster or instance is called 12-main. And every new instance get an incremented port, and we start at the default port of 5432. And the server package is PostgreSQL version, and the client package is PostgreSQL client version. And the database directory, so the data is stored in valid PostgreSQL, and the log files are in valid PostgreSQL, and the configuration files are in etc PostgreSQL. So that's actually Debian specific in a sense, because upstream and also the RPM packages, they have the configuration files in the data directory in varlib. This has some advantages. For example, if you back up this varlib PostgreSQL data, then you also have the configuration files in there and you don't need to back them up separately. On the other hand, we think that the file hierarchy standard and having everything in etc as configuration file also has some advantages. Now, I want to point out that there is a Debian-specific start.conf configuration file in there as well. along with the postgresql-conf, which is the main configuration file. And this start-conf, you can configure whether that particular instance is supposed to automatically start on boot or not, or whether it's totally inactive. And apart from that, postgresql-common also ships a couple of convenience packages or programs which allow you to interact with those clusters. So you have pgls clusters to display the info about the currently running clusters. And then you have pg control cluster, pg create cluster, pg drop cluster, pg rename cluster, pg upgrade cluster for Debian-specific administration commands. So for example, you can pg create cluster 12 main or 12 test, and it will create and initialize that cluster. Now, also you can configure the behavior of the cluster creation. There is a etc postgresql-common create cluster conf, where you can, for example, say that the main cluster, so there's always this 12 main, for example, which is installed or is created automatically when you install the PostgreSQL 12 package. So you can configure that this should not be the case. And you can also configure that your data directory should be somewhere else, maybe on a mount point, or the initdb options should be different. Maybe you want to turn on data checksums by default. And also, interestingly, you can put additional config parameters there, which are copied into PostgreSQL-conf. So maybe you want to have your logging set up for every instance in a particular way. So you can do that there. You don't have to configure every instance afterwards after you created it. You can already create them this way, which is very handy. And also there's a pgconf tool then if you want to change the configuration parameters after the fact, or you want to read them. So that's pretty handy to use in scripts. And for the client, so there's also postgresql-common client or client-common package. There's a pg wrapper script or a program which figures out what you want to do and calls the right version of a client package with also already the right connection parameters. So for example, PSQL is the main command line client, and you can just this wrapper installs itself as user bin PSQL, and you have a -- cluster option in it, which is parsed, and then it will automatically connect to the 12 main cluster like this. So this is also very handy. Right, and in etc postgresql-common user clusters or in your .postgresql-rc, you can configure which cluster should be connected to by default. Normally it's the 5432 cluster, but you can also configure that in there if you don't want to manage the cluster all the time. So right, so that's about it, what I have about the Postgres packaging. Now I want to spend a few minutes on systemd and the special systemd stuff that we use to integrate packages in the Postgres world. So I don't want to get into systemd itself very much, but I want to point out a couple of the unit file and service file things that maybe you don't know, maybe you know. So of course, you know probably that there's the foo service, systemd service. This starts and stops the service or displays the status. But also you have service templates. So you can have a foo add service. And in the service unit, then the %i is replaced by whatever you put after the add. So if you put the PostgreSQL cluster name like 11 main in there, then it can be used in the exec start section, for example, to do something based on the cluster. So you can pass that over to the command you want to run, and you can start or stop the cluster or the backup for the cluster, whatever. So that's very handy already. And also you don't just have to use services for daemons in systemd. You can also have one-shot services. So that's basically a thing that's just run once. So maybe user bin foo, maybe it does some configuration, maybe it creates something, maybe it changes something, and this is the type one-shot thing. Right, so further on, we have the generators. A generator is called foo generator, and it lives in lib systemd system generators. And this is run in boot up or when systemd config reload is run. So basically what it does, it dynamically generates or actually create symlinks to systemd unit files for example, those templates. So you can make a foo generator file which says, well, for these and that and those PostgreSQL instances, for example, make a symlink to the template. So foo at 11 main service, and those will then be started automatically on boot. This is very handy. And also you can have a corresponding foo without an add service, and that will then start all the active templated instances of this. Also very handy. Moving on, we got timers. So this is basically a cron re-implementation by systemd. So the good thing is then you can periodically run, for example, a one-shot service on a schedule. So you can say every Monday, Wednesday, Friday at 1 o'clock in the morning with a randomized delay of 2 hours, so between 1 and 3, I want to run this and that command. So this makes it also very easy to deploy cron job-like things. And then finally, we have path activation. So we can have a foo.path service or file. And this has an iNotify watch on, and it runs the corresponding one-shot service file. So foo.service. If a particular file is created or a directory is not empty anymore or something. So you can have several things there. For example, etc postgresql ** postgresql.conf. If the new cluster is created, then you can do something. So this is also very handy. So this is the stuff that we use to provide systemd glue in order to get better integration and out-of-the-box experience. So now what I want to talk two examples of things that we've integrated in Debian, which are Postgres related and useful enterprise-grade services. So the first thing is a 3-node PostgreSQL cluster with Patroni and VIP Manager. So you ask, okay, what's Patroni? What's VIP Manager? Well, Patroni is a template for high availability in Postgres. Basically, it's a project by Zalando, and it does configure and bootstrap instances, and it sets up replication, and it allows for switchover and failover. So it's basically like a bot pattern. It cares about the Postgres it handles. And what it does and how it actually manages to have leader election and split plane avoidance is via a distributed configuration store or a distributed consensus store at DCS. So it can use etcd, Consul, or Zookeeper. And those are then, well, you have to deploy those, of course, in a safe way. That means an uneven number of DCS nodes, so 3 or more. And then Patroni will create a leader key in the DCS, and whoever gets the leader key is the leader. And if this leader goes down, then the leader key expires and there's a new leader election. Or if the leader cannot update the leader key anymore, it also demotes itself to make sure that there's no split brain. It also provides a REST API for monitoring and administration. So the Patroni control CLI leverages this actually, and you can use this for status display or to have a switchover or configuration changes. Because Patroni can also edit the postgresql-conf and replicate that over all the instances. So you can do it on once and it replicates. Right, it's usually deployed in containers, so it's more like a cloud native thing, but you can do it via distribution packages. This is kind of like how it would look like. I mean, HA proxy might not be necessary to be used, but you have a distributed consensus store at the bottom, and then 3 Postgres instances, usually Patroni is handling them, 1 primary and a couple of standbys. So this is Patroni in a nutshell, but the problem is that Patroni, as I said, it's cloud native, it's a template, so it was never really well integrated into the way that Debian does things. It's very opinionated by its own how it should run, or at least how it should run by default. So it doesn't know about postgresql-common. It doesn't know about what is in cluster, what that 12 main means, that 12 is actually a version, that kind of stuff. So we packaged Patroni and we created a pg-create-config Patroni utility that creates, based on a template that we extensively tested, a more Debian-like configuration, also Postgres configuration. And it automatically creates the Patroni configuration for that. And then it assembles it out of a config YAML in, which there's a default, but you can, of course, edit it. And then there's a DCS YAML because that's for the distributed consensus store, and there the topology might not be obvious, or you might use another one. So this has to be set by the user. And then you can just system control start Patroni 12 main, and it starts Patroni, and it will either get the leader log and bootstrap, or it will clone from the leader. So then how does it work? So by default, things are where Debian expects them. So the data directory is in Warlock Postgres, the configuration is in etc PostgreSQL, and the log files are in Warlock PostgreSQL, and basically the log rotation works in a similar way. There's a bit of a problem with the configuration interaction due to Patroni also wanting to handle that, but that's solvable. And if you want to read up more on it, there I wrote a blog post which you can check out. Now, moving on to VIP Manager. VIP Manager is a Go package by Cybertech, and it pulls the DCS state of the local node. And if the local node has the leader key in DCS, it sets the VIP, and if it doesn't have it anymore, it removes the VIP. And you run it on all the Patroni nodes, and this way you have a virtual IP that always points to the leader. You configure it in, for example, etc Patroni VIP. That's a Debian thing, and there's also a Debian-specific systemd template to do this. So pg-create config Patroni can configure VIP Manager with the --VIP option, and there is another blog post I wrote about the VIP integration. So we also have a proof of concept Ansible playbook, and I want to quickly get to this now and then show you how you can deploy this in Debian. So we have it here. It's basically, there's the GitHub address, and it should be a fine master, and there's a small diff, so I set a Patroni password to make it easier to actually connect to it remotely, and I set the virtual IP address to 192.168.122.2. And now we're gonna run the playbook. So I have to say I ran it before in order to make it a bit faster. It's downloading a lot of the packages and installing them. That takes a while. So basically what it does, there is a master node. There's 3 Postgres Patroni nodes, but there's a master node, and on the master node, etcd is being installed and configured, and then the pgdg, also the app postgresql.org repository key is being installed, and the repository is being set up, and then a couple of packages are being installed, and then postgresql-common is installed, and then we disable the auto creation because we want to do it via Ansible. And then we install the Postgres server, then we set up some things, and then we install the Patroni package, we install the client packages, and then we deploy the DCS config, we install VIP Manager, and we create a Patroni configuration, and then it should be good to go. So we can log into one of them, and we can see we have nothing there. Well, let's see what Patroni's done. So probably Patroni hasn't bootstrapped yet. So if we go further, oh, there we go. And we can see that the status is recovery. So this is not the leader. And we can do this by Patroni list. So this should be the right configuration file, which is auto-created by pg create config Patroni. And we see that we have the 3 nodes, pg1, pg2, pg3, and actually pg3 is the leader node. And they're all running. And now if you want to see, I can initiate a switchover, which asks me about who's the leader and then who wants to be in a new one. Let's say pg2 should be in the new one, and we'll do it now. So then it's now switched to the leader, and the other ones will follow. This one, it takes a bit of a time, especially pg3 needs to stop and restart, and then pg1 also stops and restarts. But after a while, the timeline should be fine, and everything should be set running fine. So this is the switchover. Now, what I can also show you is the failover. So for that, I will run screen and split the screen. Run a second one here, and I'll go over here, and I have a while loop. So this runs, or maybe better to show it. So this runs, well, uses the password that I set before. That's why I did it. And then it just runs PSQL on the VIP, and it tells Postgres to just get the content of the etc hostname. So right now, PG2 is the leader. That's what we switched over to, and this is run every second time. So now what I can do, I can go over here. And actually kill. So this is LXC, which I'm using. I can shut down the leader. And this is the wrong password. I'm sorry, this is a live demo. And that's done. And yes, you can see on the other screen, it cannot connect anymore. So yes, it's down. And now the leader key will expire after about 20 to 30 seconds. So it will take a while. You can configure that, but there will be a new leader election after about 20-30 seconds, and then you should see PSQL connecting to the new leader, which is either PG1 or PG3. So PG3 won the leader election, and I can start PG2 again and get back in. And I should be able to see PG2 running after a short while again. There it is. Now it's still stopped, but now it's got running, and now the state is fine again. Okay, so back to this. I would say this is a nice way to easily deploy high availability for Postgres. Okay, so the other one is Elephant Chat. So Elephant Chat is kind of a Postgres appliance, is a fully featured web-based. So we decided to make it web-based in the sense that it's for small companies who can maybe not afford a full-time DBA position, but they still have the need to run Postgres. And so they get a fully featured Postgres installation that they can administrate basically over a web interface. So what's Elephant Chat then? It's free software. It's on GitHub. And what we looked at is our experience with Postgres projects over the last couple of years, what works, what doesn't. And we picked those that we think are really useful and or are integrating well in the web-based thing. So and put them all together under one dashboard. So we have pgadmin 4 for web-based administration. We have Prometheus and Grafana for monitoring, and we have pgbadger for logfile analysis and pgbackrest for backups, and we use Cockpit and Shell in the Box for general system administration, and SSH web-based, well, not SSH, but a web-based terminal emulator. So of course you can also SSH in, but the point is that you can also do it via browser. And this is all implemented via PostgreSQL and some systemd include via some Elephant Chat packages. And this is how the appliance dashboard looks like. So you have all the things, the monitoring, the administration, the metrics, and then you have the clusters down there. So I created a second 11 ES cluster for Elephant Chat, and I also activated the backups there. So the backups you can activate via those buttons, and then you basically get forwarded to Cockpit, where you just enable the corresponding systemd unit. I'll get to that in a second. So first of all, Prometheus. So Prometheus, basically there's an Elephant Chat Prometheus package that just ships some Elephant Chat specific configuration. Mostly we want not just Node Exporter, but another exporter, which I get to in a second, to also be scraped by default. And then we have Node Exporter, which is all the operating system metrics. And those are in the Elephant Chat Prometheus Node Exporter configuration. And you can see an example there of the CPU or the memory. So far, so good. But we also want to have metrics for the Postgres instances and databases. So we use SQL Exporter for that. slightly forked and slightly patched. And those are per instance and database metrics. So there's another package called Elephant Chat Prometheus SQL Exporter, which ships configuration, but more importantly, systemd glue. So the thing is that the SQL exporter requires a YAML file. So we assemble this YAML file automatically via update Prometheus SQL exporter config. And we use a couple of template YAMLs, activity, queries, wall, and replication. And then they have their queries on a list of queries. And then every query might also have a min or max version because some of them are not compatible. There might be different columns or additional columns. So there's different versions for different queries, or some are only up from some version. And then all of that is assembled for each instance that's available on the system. And this is all assembled to a big YAML file, and that's the configuration for SQL exporter. And if there is a new one, if there is a new configuration, so we use this path activation, then we have this Prometheus SQL exporter restart service, which basically is done if there's a new instance and a new configuration gets created, and then SQL exporter is restarted to pick this up. And then so automatically, if you create a new instance, you get the metrics. Then we have Grafana. So in Grafana, we don't want the user to have to click around and then configure Prometheus, for example. So we ship some provisioning, and Grafana allows for that. That's a pretty sweet thing. So in etc Grafana provisioning, there's a data sources and a dashboard subdirectory, and there you can drop YAML files for a data source. For example, we set it up to use the local Prometheus instance by default. So it just works. And then we also set up another PostgreSQL server overview YAML, which basically tells Grafana to import and use the PostgreSQL server overview JSON, which is the JSON representation of the Postgres specific dashboard that we're using. And that's, for example, some of the Postgres metrics that you see there, the sequential scans or insert updates, deletes, and that kind of stuff. Okay, so that's for Grafana. Now for Logfile Analysis, we use pgbadger, which is already a web-based tool. So it basically runs, so it's a Perl program which runs over a log file and then creates an HTML report. So what we have here now is we use some glue. So we have a pgbadger run wrapper script, which runs pgbadger with the correct options and directories for a specific instance. And this is being invoked by a pgbadger service template, which runs pgbadger run with the specific instance. And then we have a generator, as I mentioned before. So there's a generator which generates the symlinks for those templates, and also this catch-all thing, and a timer. So every night at 1 a.m., plus minus 2 or plus up to 2 hours, all pgbadger services run, which runs all the configured instances to make log reports for all the systems. But you can also run these as one-shots via the web interface. And last but not least, let's get to the backup setup. So we use pgbackrest, which is not web-based. So we have a couple of scripts which facilitate the configuration. So first of all, there's the etc pgbackrest.conf, and for each instance there needs to be a so-called stanza. So we add that via a pgbackrest archive command program. So this is kind of like a wrapper script, which is also being used to be run by as an archive command script. You see the next point. But if the stanza doesn't exist, it also creates the configuration there. And then it uses this path import to in order to ship the transaction logs archives to that depot. And this archive command itself needs to be set in postgresql-conf, and this is done via the pgbackrest toggle archiving tool. And this in turn is being called by the pgbackrest toggle archiving service template. And then additionally, we have a couple of timers. We have a timer for full backup, and we have a timer for an incremental backup. So the full backup runs every Sunday, and the incremental backups run every Tuesday and Thursday. And what they do is they run pg-backres run, which is another script with the instance template name or instance, and then incremental or full in order to get this done. And this also can be done via a button at or a start via cockpit over the web interface. So that's it for the systemd integration here. To recap, the Elephant Chat is a fully fledged appliance which lets you monitor and run and administrate PostgreSQL from a web-based thing. And so the current status is basically we're using, so pgadmin 4, we use the app postgresql.org packages because they're not in Bullseye yet, or in Unstable because there's a couple of packages missing. It's had lots of Python packages. And we use the upstream Grafana package because I believe it's not packaged in Debian. But otherwise, we use the Debian packages. So we use the Debian Prometheus package, Node Exporter, SQL Exporter, pg-backres, pg-badger. We use the Debian packages. But we have these additional Elephant Chat glue packages, and those are available from packages.creative.com, or you can build them from the GitHub repository. Maybe, for example, those pg-backres support scripts that I mentioned in the previous slide, like pg-backres toggle archiving, pg-backres archive command, pg-backres run should be part of the pg-backres Debian package because they're generally useful for Debian installation. But okay, we have to see how those integrate or how that works. Some words on how you can install Elephant Chat. You can run also as an Ansible playbook, but we have also Vagrant boxes and virtual machines, so you can try it out like this. So this is also very easy. And then maybe some future directions. So we also created the PG API, which is a REST API for postgresql.com. So then you can, for example, run curl get on your local thing and get all the clusters. And this runs then pgls, something similar to pgls clusters, but you get a nice JSON output out of it. And then also we want to be multi-host at some point, and PG API will help in that, so that you're able to administrate from one head node, maybe several PostgreSQL servers, which might not have need all this Apache web-based thing then. So that's about Elephant Chat. Now maybe a couple of words about what's new in PostgreSQL for Bullseye, because maybe that's also interesting for some of you. And you can ask some more in the Q&A if you're interested in some specific points, but I'll just go over this quickly. So PostgreSQL 13, as I mentioned, Postgres has a pretty reliable 1-year release cycle now, and it has a time-based freeze, and then it releases when it's ready. So it's pretty similar to Debian in that regard. So we expect the PostgreSQL 13 release in September or October. There was a second beta, I think, a couple of days ago. And then we also expect that Bullseye will ship PostgreSQL 13. We'll see how that goes. So the main features, I mean, of course, there's quite a lot of features, but maybe the main features, you could say that it's getting better again, even better for large data scalability. So for example, the standard B-tree indexes, they got deduplication now, so they are much smaller in some cases, mostly for unique indexes, I believe. And that makes a lot of, if you have a lot of data, then and those are actually like only half as big or something. That's not like 5%, it's really 50% or something. So it's a huge improvement for B-tree indexes. And if you have a lot of indexes, then that's very important. And you can also have disk-based hash aggregates. So aggregates before wouldn't be done unless they fit in the work memory that you assigned. And if that was too small, it wouldn't work. So if you have lots of data, it would actually never do a hash aggregate. But now it can actually spill to disk. Of course, that's slower than memory, but you can at least do a hash aggregate then, which you couldn't before. You can also have statistics targets on extended statistics. So extended statistics have been introduced a couple of releases back for correlation between several columns, for example, and you can improve and say make it more, do more sampling, make the statistics better for those extended statistics. And that's also very important if you have lots of data and you have bad plans. Postgres has then will be able to figure out how to access your data more easily. There's also some partitioning improvements. For example, now you can have a logical replication from partitions, so this makes it easier to set up big data and partitioning in general. Parallel vacuum is also a big thing. So vacuum needs to be run in Postgres. And this is kind of a pain point, and you can now run it in parallel, and at least the cleanup phase and the index phase will be done in parallel. And this can, if you have lots of indexes on a relation, on a table, this can make a huge difference. And then there's backup manifests. So they keep all the files that are in a base backup along with the hash of the file, and you have a corresponding PG verify backup tool where you can verify that all the files in the base backup are still good. And then there's better progress monitoring. So for example, now you can, through a SQL connection, see whether the base backup is running and how far along is it, or how far along an PG analysis. You can also get some statistics on the commit log and that kind of thing. And then, quite interestingly, I think is slow query sampling. So you can tell Postgres to tell you the statements that it's running, but maybe only every 100th statement or every 10th statement. So it's a percent sampling. So you know what's going on, but you don't have to log everything. But also, it not only logs slow queries. So this is very interesting to figure out what's going on a server, and you don't know what's exactly going on. And then also there's trusted extensions, which mean that non-super users can create those extensions. That's particularly useful, potentially useful. Now, last but not least, a couple of new extensions that have been introduced since Buster. So I want to point out OmniDB, which is a full-fledged web tool for database management, similar to pgadmin 4. As I mentioned, pgadmin 4 is not yet in Unstable, so maybe you will manage to get it, but it doesn't look very good. And there's VIP Manager, which I mentioned before, so this is also new. And then a couple of new packages like PG Point Cloud, which is an extension for storing point cloud data like LIDAR. PGCLUU is a performance monitoring and auditing tool, which is pretty handy and pretty powerful. Then a couple of system catalog checker, for example, or source indenter. That's maybe not so important, but there's a couple of new extensions that expose additional SQL functionality like first last ag for aggregate functions or extra window functions to improve the thing. So with that, I'm at the end. And I'm waiting for, thank you for your attention, and I'm happy to answer any questions if there are any.
Mikhail, thanks a lot for your talk. So now let's answer some of the questions. Does BitManager work across data centers? Do all Postgres instances need to be in the same subnet?
So, in general, Patroni can work across data centers, but then you have to make sure that usually you need 3 data centers, because with 2 data centers, it's where you cannot get quorum. So this is problematic. VIP Manager, I would not recommend that. I think VIP Manager is a useful solution for a local 3-node cluster, but you don't really have to use VIP Manager. Really, you can use client-based failover or a proxy or some other things. So I would not recommend using VIP Manager for multi-data center setup.
Great. Next one. How do you test Patroni? Do you rely on the DCS working properly and only test against the DCS config, or do you stop fail nodes?
So, well, how do you test Patroni? I do test Patroni by deploying it in smoke tests, but Patroni also has a pretty good test suite itself using Behave, I believe, and unit tests. So this Behave test suite, you can have a look at it. It's pretty comprehensive, and it does spin up, I think, several 3-node Patroni clusters locally and starts and stops them. But, well, it's not really a pull-the-plugger test.
Okay, the next one. Will Grafana appear as dev package?
So that's a tough question because I haven't really looked at Grafana. I assume it needs lots of rendering. I think it's a Go application. So for Grafana to make the package, it's probably just dropping the Go binary somewhere. And it's probably very complicated to do it as a proper Debian package. So I don't know really. I would have to look more to it, but I'm afraid that it's probably not forthcoming. So I don't even know whether there's ongoing packaging, I have to say. So we'll have to get back to that.
Great. So thanks a lot for your talk and your responses, Mikhail, and keep enjoying DebConf 20.
Thanks.
Thanks.
Bye.